All right, so ladies and gentlemen, we're going to need to make three of these charts right here. Three different columns with 5 rows. The first one is milliliters, M with a lower, or with a cursive M, excuse me, an M with a cursive L for milliliters. Second column is a cursive G for grams. And the third column is density. And the symbol for density is G over ml, milliliters. All right, so make 3 of those columns. Now, pause this if you need to while you're making the columns. So density is a measure of how much matter is in a given amount of space. So grams is a measure of how much matter there is. It's called mass. We measure that in grams. It is the total amount of matter. This is the way you say it. Grams is a measurement of volume, how much space matter takes up. So if we are measuring how much matter there is in a given space, it's called density. And I think I'm explaining that kind of right. So density is how much mass is in a given amount of space. And we learned a lot about density. We talked about density when we were exploring the gases. We know that carbon dioxide, nitrogen, and argon were all more dense than air. So they were more dense, they were quote unquote heavier, so they sank to the bottom. So what we're going to do is we're going to look at the density of 3 different liquids and just see, how you measure density. We're going to experiment with that a little bit. What I have here, this is called a graduated cylinder. These are milliliter marks. This is a 100 milliliter graduated cylinder. We have units of 10 going up with each line individually put in there at 1 milliliter. So to do this, try to get a good angle on it. I might actually have to go freehand with my camera. So we're going to turn the scale on. And we have 0, and you can see over here is a G. Nope, I'm sorry. The G is right over here at the side of the 0, indicating that my scale is in grams, and that's kind of a blurry picture. I'm going to put my graduated cylinder on here, and you can see the graduated cylinder weighs 110 grams. But I don't want to measure my graduated cylinder. So what I'm going to do is I'm going to hit this button right here that's called 0. I'm going to press it, and even though the graduated cylinder is still on the scale, my scale now reads 0. I'm going to put the camera up here for a second. You know what I need to do? I need to get a flexible camera mount for my camera. That way I can move it a lot easier. What's that?
So are we supposed to write down like the milliliter and the gram stuff?
Not yet.
Okay, thank you.
As soon as I measure in the water. So what I'm going to do is I'm going to measure 25 milliliters of water. That is going to be my first measurement. So go ahead and write down the volume is 25 milliliters. Milliliters, yes. Milliliters is a measurement of volume.
Wait, so
We put this in one of our graphs, 25 milliliters, right?
Yes, you will put that in the very first column, and I'll show you here. So this is for water. So I got water right here, and I'm going to put down 25 milliliters. Put this up here, so. All right. Now, when you look at the graduated cylinder, what is important to note is when you look at this, you have a curve on the liquid. It's kind of hard to see. This is not the clearest focused camera, but the sides are up a little bit higher than the middle. I want the middle to be on the 5 milliliter or the 25 milliliter mark, and that's what it is. It's at 25 milliliters. If I look at my scale, it is 24 grams. So I will measure right here, 24 grams. And notice that when I'm writing it down, I am putting the unit of measure with each one. I have 25 milliliters and 24 grams. Now, because my math is lacking, I'm going to use my calculator. We divide grams by milliliters. So I have 24 divided by 25, and I come out with 0.96 grams over milliliters.
So our answer is 0.96?
0.96 grams over milliliters. All right. Now I'm going to go to 40 grams, or excuse me, 40 milliliters. So I have 40 milliliters. And my mass is at, can you see the scale, or is there's light on it, isn't there?
Yeah, there's a little bit of refracting light.
Does it say 91? Because if it's not, then no, I can't see it.
No, it is 40 milliliters and 40 grams. So you'll write down 40 milliliters and 40 grams. Now, I am not a rocket scientist, but I know this, that gives me 1 gram over a milliliter. So the density is 1. Last time I checked, 40 divided by 40 equals 1. Does anybody need to double check my math on that?
You should try the calculator.
Yeah, just to be safe.
My calculator gave me an error. It told me I was stupid.
I think the answer is syntax error. That's what the question is.
All right, now we're going to do 50 milliliters. So 50, you can go ahead and do this too. It's going to be 25, 40, 50, 60, and 70 milliliters.
So after 50, it's 60 and 70?
Yeah,
Okay, thank you.
you're welcome. And my scale comes out to 49 grams, which should be around 0.96 again. Let's 49 divided by 50. Oh, 0.98.
Wow.
I don't know. You can call Motorola and tell them their calculator's wrong if you don't believe it.
Can I check on my Chromebook calculator?
Sure.
Just to be safe.
And there's the grams reading right there.
49. 50.
Going to 60 milliliters now. $60 milliliters of water, 60 grams. Again, not a rocket scientist, but 60 divided by 60 gives me 1 gram per milliliter. And then finally, we'll go to 70. Oops, hair over. Hair under. $70 milliliters. $70 grams. Once again, giving me 1 gram over milliliters. Do you all concur with what I have?
Yes, but I feel like since all the 10 so far have gotten themselves, you think the 49 could have been like 50, but it was one off?
Okay, so here's what I'm doing. You know, I kind of show you with the camera, but my camera is blurry when we come in. Do you think possibly that's human error?
No, I think that's computer.
I would probably go with human error. And the other thing is my scale only reads whole numbers. So, I mean, it's very possible the 24 or the 49 was 24.9999999, just hair off. But again, that's human error. That's me not having the precise amount on there. If I were to add all these up, what is my average for the 5 of those? So let's see here. I have 0.96. Oops, clear my screen out. 0.96 plus 1 plus 0.98 plus 1 plus 1 equals 4.95 divided by 5. So my average is 0.988 grams over milliliters. Now, I don't know how many of you remember this, but when I first introduced the term density to you, the standard unit for density of water is 1. It's 1 gram per liter, or 1 gram per milliliter, excuse me. It's also considered to be 1 cubic centimeter. So if I take 1 cubic centimeter of water, that should weigh 1 gram, which also gives me the density of 1. So because I have 3 at 1 and 2 just under 1, I'm going to say that was human error. Rashish, you're asking me to show you. Oh, yeah.
So, Mr. Schillinger,
Yes.
if we had like a computer do this for us, and it was exactly like very precise and gave us exactly 25 milliliters, we would have probably gotten 25 grams.
According to science, yes. You should have exactly 1, the density of 1 every time.
So just for fun, can we put in 1 gram of water and see what happens?
Not with this scale. Hold on 1 second. I said not with this scale. I meant not with this graduated cylinder. So I've gone and grabbed a smaller graduated cylinder. So I'm going to put the graduated cylinder on here, zero it out. Let me try and get 1. One gram of water is not a whole lot. One gram, 1 milliliter. Okay, so now we are going to go to glycerin. So basically what I need you to do is go to your next chart. I'm going to erase mine real quick.
Are we doing like the same amount of milliliters as
Yes.
the water?
Yeah, I didn't actually need to erase those. 25.
Wait, so Mr. Schillinger?
Yes.
So the 3 charts are water, glycerin, and what's the last one?
Alcohol.
Okay.
All right. So I'm going to, I've put a new graduated cylinder on here, not the one that had water in it. Actually, that reminds me, I'm gonna dump that back in there, let that dry out. I am, actually, let's do it this way. I am zeroing out my scale with the graduated cylinder. So this is a bottle of glycerin. Glycerin is, I'm trying to, it's like it's part of lotion. It's used to soothe skin. It's you find it in food. You find it in all kinds of stuff. It's made from vegetables. It's kind of an oil, but it's not really an oil. One of the big things that you use glycerin for is actually to make bubbles. Like if you've ever had a bubble wand, glycerin is one of the ingredients that helps thicken the water up.
So you can just buy glycerin at like Walmart?
Yep. This is the Equate brand, which is the Walmart brand of products.
Is it edible?
It is edible, except for I don't believe you'd want to eat it, not by itself. It may might help you go to the restroom a little bit.
Okay.
Yes. Somebody said Mr. Schillinger?
Yeah. So my sister actually got for her birthday I think it was 2 years ago, she got this make your own lip gloss kit
Okay.
for her birthday, and inside that there was glycerin, and then there were these food colorings that you put in, and it's supposed to look like a lava lamp. So I
Okay.
just thought we'd add that in.
Yeah, because you'd put it in your, like on your lips, because it helps moisturize. Oops. Not quite there. This is really thick, so I got to go slow, make sure I don't go over.